Have you ever looked up at the night sky and wondered, what did the universe sound like when it was born? What if I told you that we can actually hear the echoes of creation, not with our ears, but with our most powerful telescopes? This isn't the sound of an explosion, because the Big Bang wasn't a bang at all. It was a moment of incredible expansion, where everything, all of space and time, burst forth from a point smaller than an atom. So how do we listen to a whisper from 13.8 billion years ago? How do we trace this ancient echo from a tiny, hot, dense beginning to the vast, star-filled cosmos we see today? That's the journey we're starting right now. The most direct echo of the Big Bang isn't a sound, but a light. It's called the cosmic microwave background, or CMB for short. Imagine the entire universe, just after it began, as a super hot, dense, glowing fog. Nothing could travel very far without bumping into something. For about 380,000 years, this was the state of everything. But then, the universe expanded and cooled down enough for the fog to clear. For the very first time, light was set free to travel across the cosmos unimpeded. The cosmic microwave background is that very first light, now stretched and cooled over billions of years, filling every corner of space. It is quite literally the oldest picture of our universe. But this ancient light is more than just a baby picture. If you look closely at the map of the CMB, you'll see tiny, almost imperceptible differences in temperature. Some spots are a fraction of a degree warmer, others a fraction of a degree cooler. These tiny fluctuations might seem insignificant, but they are everything. They are the seeds from which all cosmic structure grew. The slightly denser, cooler spots had a little more gravity, pulling in more matter over eons. These were the birthplaces of the first galaxies, the first stars, and eventually planets like our own. Every star you see, every galaxy spinning in the void, and even the atoms that make you, all trace their origins back to these tiny ripples in the universe's first light. We are, in a very real sense, the descendants of these cosmic whispers. So how do we listen to this ancient light? We use incredible instruments, marvels of modern astronomy, to capture this faint cosmic glow. Telescopes like the Planck satellite and its predecessor, WMAP, were launched into space to create incredibly detailed maps of the CMB. Think of them as cosmic archaeologists, carefully brushing away the dust of billions of years to reveal the universe's foundational blueprint. By studying the patterns and fluctuations in this primordial light, scientists can do amazing things. They can rewind the cosmic clock and calculate the age of the universe with stunning precision, 13.8 billion years. It's like finding a birth certificate for the entire cosmos, written in the language of light. But that's not all. This echo tells us what the universe is made of. The results were shocking. The stars, galaxies, planets, and all the stuff we can see, what we call normal matter, makes up only about 5% of the universe. The rest is a complete mystery. About 27% is something called dark matter. We can't see it, we can't touch it, but we can detect its gravitational pull holding galaxies together. Without it, galaxies would fly apart. Then, the biggest piece of the puzzle, about 68% of the universe, is an even more mysterious force called dark energy. This is the force that's causing the expansion of the universe to accelerate, pushing everything further and further apart. The CMB gave us the first solid evidence for this strange cosmic recipe, revealing that we live in a universe dominated by forces we are only just beginning to understand. But light isn't the only echo from the dawn of time. Imagine dropping a stone into a perfectly still pond. Ripples spread out across the surface. Now, imagine that the pond is the fabric of space-time itself. Albert Einstein predicted over a century ago that massive, violent cosmic events could create ripples in space-time, called gravitational waves. For decades, this was just a theory. But recently, we built detectors so sensitive they can feel a distortion in space-time smaller than the width of a proton. And with them, we have detected these waves. We've heard the collision of massive black holes and the merging of neutron stars, events so powerful they shake the very structure of the universe. These gravitational waves are a completely new way to observe the cosmos. They aren't blocked by dust or gas, so they travel to us directly from the heart of the most extreme events. They are the universe's unseen resonance. This discovery opens a breathtaking new frontier. The gravitational waves we've detected so far are from relatively recent cosmic events. But scientists are now on the hunt for something much older, much fainter: primordial gravitational waves. These would be echoes from an even earlier time than the CMB, from the first fraction of a second after the Big Bang, during a period of hyperfast expansion called inflation. If we can detect these primordial waves, it would be like hearing the first heartbeat of the cosmos. They could unlock secrets about the very moment of creation, telling us about the fundamental forces and physics that governed the universe's birth. We would be peering into an era that was once thought to be forever beyond our reach. The hunt is on, and the potential discoveries are mind-boggling. So, what does all this mean for us here on our small blue planet? It means we are profoundly connected to this grand cosmic story. The Big Bang wasn't some distant event that happened long ago and is now over. It's an ongoing process. The expansion that started 13.8 billion years ago is still happening right now. The universe is still growing, still evolving, and we are along for the ride. Every atom in your body, the carbon, the oxygen, the iron, was forged in the hearts of stars that, in turn, were born from the seeds planted in the cosmic microwave background. You are literally made of stardust, which is itself made from the raw material of the Big Bang. When we look out at the cosmos, we are looking at our own origin story. From the first faint light to the unseen ripples in space-time, we are constantly learning to decode the echoes of the Big Bang. Each discovery gives us a clearer picture of our universe and our place within it. It's a journey filled with wonder, driven by our unending curiosity to understand where we came from and where we are going. The universe's echo is still ringing, and it has so much more to teach us. We just have to keep listening. Thanks for watching this cosmic journey with me. If you're as fascinated by this as I am, don't forget to like, subscribe, and hit that bell to join us on our next exploration.